Ladies and gentlemen, welcome once again to the Trigonometry Chronicles. Fraser Nation on deck. It's your host, Timothy Fraser. Um, I want to remind all my seniors and my juniors, these notes are due when you walk in Monday and Tuesday. Okay? So hopefully you're looking at this video now. Everything you see on the screen needs to be in your notebooks. And I'm going to warn you, it's a lot of steps in these following problems. Okay, it's a lot of steps. It's easy work if you pay attention. Please write down everything because I've tried to go step by step to help you out. Okay. If it was me, I would use flashcards and the problems that I do and submit up to you in Schoology. If you need more practice problems, let me know. I will send something else out for you guys. But for now, let's get the lecture in. 5.5 is about solving right triangles. Okay? So basically, we're taking 5.2, 5.3, 5.4, we're putting them all together, and we're going to take a right triangle and solve the whole shebang. So the objectives here, there's three things you need to be able to do in this lesson. Students will be able to evaluate inverse trigonometry functions. You don't know what that is? I'll share with you in a second. Students will be able to find missing angle measures, inverse trig functions, wink wink. And finally, students will be able to look at the title, solve right triangles. I need you to remember a few key things. Number one, solving right triangles means calculating all the side lengths and all the angle measures of right triangles. Now, obviously, one of those is always given to you, and that's the right angle. So you have 5 things that you need to do here. Next is SOHCAHTOA. Let's remember the S is sine, C is cosine, T is tangent, and the OH, the AH, and the OA are the fractions you're supposed to be given once you give that trig ratio. The word inverse means opposite, so you'll see what that means in a second when we talk about inverse trig functions. The symbol theta is the unknown angle measure, okay? That's going to be very important in this next card I give you. The Pythagorean theorem, you're going to need this, people. C squared equals A squared plus B squared. C is always the hypotenuse. So only plug something in the C if it's across from the right angle. Angles in a right triangle use capital letters. The opposite sides from those angles are the lowercase letters. So if you got angle capital A, then its opposite side is going to be lowercase a. And finally, and I cannot stress this enough, when you're using calculators, do not round until the very end, okay? If you get some big ugly decimal in the middle of a problem, you need to type that whole thing in to the next step until you get to the end, all right? One thing I will say, I won't write it down, but hopefully you're listening to this as well. When it says round to the nearest tenth, that means the very first decimal place after the decimal. So hopefully you remember that. Next card. Okay. The one thing that we need to know is calculating the angle measures in the right triangle. So the opposite of finding the sides of a right triangle, this is when you use trig functions, is when you're trying to find the angle measures of a right triangle. This is where your inverse trig functions come in. So you're using inverse sine, inverse cosine, and inverse tangent. I'm sorry that it's all switched around like this. But I want you to notice something. First of all, let's use SOHCAHTOA, okay? Let's go ahead, throw that in, okay? And hopefully you're pausing this video, getting everything in. That's the whole purpose of flipping these young classrooms of mine. So when we have cosine of theta is equal to what? Your adjacent side over your hypotenuse. So whatever number is the adjacent divided by the hypotenuse, that's equal to cosine of theta, okay? Now, the inverse trig functions, I can take and cancel that out, okay? and get, if I take this number and plug it into my inverse trig function, I would have adjacent over hypotenuse and close the parentheses. So in your calculator, you would have cosine, inverse cosine is, and then this is inside your function, and that's going to be equal to your angle measure. Okay. Now I know that's not making too much sense right now, but let's go ahead and write these out. Okay. And I will throw you a small example in a second. Okay. And this is going to be opposite over adjacent. So opposite over adjacent. The one thing that I really want to point out is we are working with functions and functions. So we're plugging stuff in. So let's say I have a small triangle, and let's call it a right triangle. And let's say 3, 4, and 5. Okay. But I don't know this angle. I don't know angle A. I can use my two sides that I already know to figure out what the angle measure of angle A is. Okay. So if I were to say tangent of A, okay, remember tangent of A is equal to the opposite over the adjacent. So here's your opposite, here's your adjacent. So tangent of A is equal to 3 over 4. Okay. The inverse trig function is going to tell us what angle A is equal to. Okay. This, my people, is your algebra 1. We're going to use inverse operations. We need to get rid of that tangent. Okay. We need to get rid of that tangent. So I'm writing here inverse operation. So that means that on both sides, I'm going to apply my inverse tangent to both sides of the equation, okay? So I'm using this inverse tangent. I know it says tangent raised to the -1 power. Don't say that. Say inverse tangent of tangent of A is equal to the inverse tangent of 3 over 4, okay? So this is a function, okay? Now, the reason I keep saying inverse, remember, inverse operations cancel. So we have the inverse tangent and the regular tangent. These are going to cancel. And you are left with, surprise, surprise, angle A. And then, where is angle A coming from? It's coming from the inverse tangent of 3 over 4. Okay? And when you plug this in your calculator, and remember, calculators must be in degree mode. We are in degree mode, so somewhere on your calculator, it needs to say DEG, not RAD. Okay? We're not using that. We need to be in degree mode. When we type this into our calculator and we round to the nearest tenth, that's going to be to 36.8698, blase, blase, blase. So the angle measure is approximately, remember I wanted you to round in tenths, 36.9 degrees, okay? So what did I say? I'm finding the angle measure, so I know that angle A, okay, the measurement of angle A, is approximately 36.9, okay? That's a small example, but I want to say, when you plug into an inverse tangent, you are finding the angle. When you are plugging into an inverse cosine, you are finding the angle. When you plug into the inverse sine, you are finding the angle. Okay? This is something new. Let's go ahead, go to the next card, and get some examples in. Okay. Now, before we do the examples, write these steps down, okay? There are two types of problems when we're talking about solving right triangles. You can either be given two sides of a triangle. So let's say, for example, here's my triangle, here's my right triangle, and I'm given like 16 and 9, okay? Something's always going to be the easiest to find. It's either going to be the third side or it's going to be the third angle. And let's go ahead and put a triangle here while we're talking about it. Okay, so I will use the Pythagorean theorem, step 1, to find this third side. Let's call this angle A. Side A. Okay, C is always the hypotenuse. So C, 16 will go inside for C. Step 2, use two sides, and preferably you use the sides that they give you. Okay. Use the two sides with the inverse trig function to find the first angle measure. And then you're going to take whatever number you found in step 2, subtract from 90 and find the third. That's supposed to say angle. Y'all fault. Put angle right there. Okay. Now, if I'm given two angles, remember I told you, you're always going to get 90. Okay. Let's call this like angle 26. Okay. So if I have two angles in a problem, step 1 is to figure out what that third angle is. So you would take the non-right angle, so not this one, but 26, and you will subtract from 90 to find your third. Wow, I can't believe I did that again. Third angle. Okay. No, step 2. Use a given side length. They're always going to give you a side length, okay? They will always give you a side length. Use a given side length with the appropriate trig function to find a second side. So if you're given 26, this is your opposite. So remember, you can use sine for opposite. You can use tangent for opposite. Doesn't matter which one, because you're going to have to find that second side. And then finally, you're going to use sine, c squared equals a squared plus b squared to find the third side. Go ahead and write these down. Okay. I have 2 pre-examples for you, then I have 3 real examples for you. And then I'll upload your homework to Schoology, and then you'll be ready for a discussion on Monday and Tuesday. Next card. Okay, here's a pre-example. Okay, I'm not going to solve this whole right triangle. I'm going to just only solve what they asked me for. Okay, so in this triangle, if little r is equal to 7, okay, remember the lowercase letters are your sides. Okay, so I know that st has to be 7, and I know that little s has to be 10. I want to find the measurement of angle R. So how do you do that? Well, first and foremost, we know that we have R, okay, and we have the opposite of R and we have the adjacent of R. We don't know anything about the hypotenuse. So we know the opposite and we know the adjacent, okay? So opposite, adjacent, and we know SOHCAHTOA, okay? You guys see how important SOHCAHTOA is. We have opposite, we have adjacent, so we must be using tangent, okay? Let's go ahead. All right, so tangent of R is equal to opposite, which is 7, over 10. Okay? I want to solve for R, so I need to get rid of this tangent. Well, how do you get rid of a tangent? You use inverse tangent. So here's inverse tangent. Tangent R is equal to the tangent inverse of 7 over 10. Okay, remember this is a function. So we did that because we want to cancel out inverse tangent and be left with R. R is equal to the inverse tangent of 7 over 10. And when you plug that thing in the calculator, and remember, it's supposed to be to the nearest 10th, we get 34.992. And we're rounding to the 10th, so if we round, this 9 is going to make this 9 go up, and the 9 going to roll over. So this is approximately 35.0 degrees. Questions? Pause the video, write this stuff down, and I'm going to go to my next pre-example. Okay. So now, B says, if R is equal to 12, let's write that down in our problem. If R is equal to 12 and T is equal to 20, find S. Okay? So we don't know the opposite, but we know the adjacent and we know the hypotenuse. So we know angle S, we know adjacent, and we know hypotenuse. Looking at SOHCAHTOA, adjacent, hypotenuse, so we're talking about cosine. So this is going to be cosine of S. Okay, remember we're finding big S, so that's an angle, is equal to the adjacent, which is 12, divided by 20, which is the hypotenuse. I want to get rid of this cosine, so I have to use the inverse cosine. Y'all notice I keep saying that? The inverse cosine of S, which is equal to the inverse cosine. Remember, whatever you did to one side of the equation, you did to the other side of the equation. The inverse cosine of 12 over 20. We do that so we can cancel out these two cosines, and you are left with S equals inverse cosine of 12 over 20, which is approximately, and I'm just going to give you the 10th on this one, 53.1 degrees. Okay? So in your calculator, you're going to want to put parentheses around this. Okay? You're going to want to do that, especially my people who are at home using the calculators I showed you on iPhone and Android. Use parentheses, especially Android. Okay? Pause it so you can get this work down, and let's go to the 3 examples. Okay? All right. So, we're 18 minutes strong, but I want to make sure you got this down. So I'm going to do 3 examples, okay? This one, I am given 2 angles, okay? So in those steps that I gave you, I am given 2 angles, okay? I'm given my right angle, and I'm given B, which is 78. So remember, step 1, let's write this down. Step 1 is to find the third side. So I'm going to take 78 and subtract it from 90. Okay, so 78 taken away from 90, that's S1. Okay, let's say step 1. Let's be cool about this. Step 1 is going to be 90 minus 78. So we are given 12 degrees. Okay, and this is equal to the angle that we are not given. Okay, so this has to be 12 degrees because 78 plus 12 is equal to 90, and there's 180 degrees in every triangle, so that's where that's coming from. Step 2 is the given side, okay? So the given side is 41. And that shouldn't be degrees, that's just 41. Okay, so step 2 says we're going to take the given side and we're going to use an appropriate trig function. Now, I'm not going to use this 12. I'm going to use 78 because they gave me 78. Okay, so I'm going to take this 78 and I'm going to use this 41. Now, this is not an opposite. This is not a hypotenuse. This is an adjacent. So I have two choices when it comes to using adjacent. Okay, I can use cosine or I can use tangent. Okay, now being that adjacent is going to be at the bottom, I'm just going to use tangent. Okay, it's going to be an easier calculation that way. You can use cosine, you will get the same answer, but I'm going to use tangent here. Okay, and I'm using tangent because tangent has adjacent in it. I can't use sine, but I can use cosine of tangent. Tangent is going to be easier for me. So tangent of 78. Okay, remember I'm using the angle that they give me. So tangent of 78 degrees is equal to the adjacent, the opposite, which is B, okay, divided by 41, which is the adjacent. Okay, so in order to solve, I need to multiply both sides by 41 times tangent of 78 degrees equals B. So approximately B is 192.9. Okay. So I know that B is 192.9. And then step three should be the easiest for you. Let's put step 3 right here. Step 3 is when you use C squared equals A squared plus B squared. So here's your A, here's your B. We don't know C, that's what we're solving for. So C squared is equal to, we don't have our hypotenuse, 41 squared plus 192.9 squared. Plug that in your calculator, okay? This is going to be 41 times 41 plus 192.9 squared, and that's going to be 38,891.41. That's what C squared is equal to. And how do you get rid of this square? You got to square both sides. You got to square root both sides. So C, and let's go ahead and put that in blue, or this little strange flesh color, so that way you guys don't forget. That's what we're doing with square rooting. C is equal to 197. That's not supposed to be a 2. Okay, 197.2. Okay, so here's my angle. Here's my angle, here's my angle, here's my side, and here's my side. Okay? All right. For sake of time and sanity, I'm going to go ahead and just write out the work for these other two problems. So let's go ahead and do that. Okay. I'm going to speed up a little bit here. For B, I'm given two sides. Okay, so I know A is 11. I know B is 21. Okay, and so step 1 is I have to find that third side. So I have to use C squared equals A squared plus B squared. Okay, I don't know my hypotenuse. So C squared is equal to 11 squared plus 21 squared. 121 plus, what's this, 441? So that's going to be a 2, a 6. So it's going to be 562. C squared is equal to 562. Square root both sides, so you can cancel this square root and this square. And then C is equal to, get that equal in there. C is equal to 23.7. Okay, so So this is 23.7. Step 2, I'm going to use my two sides that I was given, okay, to find an angle. Doesn't matter which one you pick, okay? You can choose A or B. I'll choose A. Okay, so I know that opposite and adjacent from A, I'm just choosing A, okay? Opposite of adjacent, that's tangent. So I'm going to use tangent A equals the opposite over the adjacent. So 11 over 21 tangent inverse of tangent of A equals 11 over 21, and that's not 11 over 21, I apologize. That's the inverse tangent, because whatever you do to one side, you got to do to the other side. So this is tangent inverse of 11 over 21. Cancel out. A is going to be approximately, once you plug that in, 27.6 degrees. Okay, so 27.6 degrees. And then step 3 is take and subtract this from 90. So B is equal to 90 minus 27.6 degrees. So that's going to be about 62.4 degrees. Okay. 64. I'm sorry. That's supposed to be 62.4 degrees. Okay. And then finally, okay, if your mind isn't numb like mine is, because I know we're running out of time here, but let's go ahead. Let's write this third one out. Okay. How about we wait a couple of minutes? I should just like give you guys the answers, so that way you can compare what you get to what I get. But no. Okay. Let's see, 32. So that means that we're given two angles. We're given the right angle. We're given 32 degrees. And then we know C is 13. So step 1, 90 minus 32 is equal to B. So B is equal to 58 degrees. So put 58 there. Step 2, use the angle that you were given in the problem. And this is hypotenuse, so we can use either sine or we can use cosine. It does not matter which one you use. I'm going to just use sine. So sine of A is equal to the opposite, which is A, over 13. Okay. You got to multiply both sides by 13. So I got sine. And I'm sorry, that shouldn't be an A. You should have sine of 32 right here is equal to A over 13 times 13. Cross these things out, and you are left with A is over here, and so this is 6.9. Go ahead and put that in your triangle. This is 6.9. And finally, step 3, we have the Pythagorean theorem. So C squared equals A squared plus B squared. And we know C, so this is going to be 13 squared equals 6.9 squared plus B squared. Let's see, 169, which is equal to 47.61 plus B squared. So we know that this is 121.39 when we subtract on both sides equals B squared. And so now Square root both sides. We know. And we finally get B is approximately 11. Okay. Yes, I know the video is 30 minutes long. I get that. But we have 5 examples. We have 2 pre-examples, 3 examples. I'm going to upload the book page for you so you can attempt the homework. I'm just going to tell you right now, you can go ahead and show me the work. Okay? And I'll write the assignment that I expect for you guys on the PDF. And yeah, that's pretty much it. All right, guys. I'll see you Monday and Tuesday. Bring me my notes. We need the grade so we can go ahead and put these in the grade book. Peace!